All right, squad. So energy. How do we get it? What do we use it for? And we're going to kind of walk through some of those processes. But energy at its simplest form is a calorie. So the way that we measure calories, just so everyone's on the same page, is through kcal, and we measure this by how much heat energy is required to raise it from 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. But at the end of the day, what you need to pay attention to is calories, right? So 1 kcal is going to be equal to 1 calorie in uppercase. So these are the two that we use that you would see on the back of the label. The calorie that is in lowercase c, you guys, is something different. So I just want you guys, just in case you're a little confused, well, about calorie and calorie, the capital A C and the lowercase c are two different meanings. So, energy metabolism is the study of how the body stores and burns energy. So essentially what happens is we intake some type of macronutrient, right? Carbohydrate, fat, protein, or water. We add in respiration and we have some sort of ATP reaction that occurs and we have heat that is lost. When we ingest food, we digest our food and we create a form of energy. And without energy, we would not have life. So every day, our body has some sort of chemical reaction that occurs from the primarily carbohydrate and fats that we have, and sometimes others like protein. We then have ATP that is produced, and this is our body's energy currency. You can think of it as money. We can't do anything without ATP, and we need ATP in order to daily function, and then that generates metabolism. From these reactions, we then have chemical waste that is let out. We have heat that is let out from not only the production of ATP, but also from metabolism. So the concept of energy is the capacity to do work. Exercise is the capacity is determined by how much energy in the muscle cell and how quickly the energy is available. Fatigue is going to occur when the rate of the energy demand exceeds the rate of the energy production in skeletal muscle. Okay, so let's break these down. Energy is your ability to do any work. Work can be walking to your car, work can be taking a shower, work can be any type of like daily function that you have. When it comes to exercise, everybody, we are going to be limited by to how much energy the muscle cells have available to it, and how quickly the energy is available. So depending on what type of exercise you're doing will limit these two things, whether you're going on a long run, whether you're going to lift weight, whether you have ate something that day, whether you have not ate anything that day, if you've had a really low carb based diet. Does that make sense? So our availability to do exercise will be determined by our body's ability to make energy available to it. And then fatigue is going to be when our demands, so what our body needs to keep going, is limited by the rate at which we can produce energy. Okay. So if you've ever had a time period where you've had a really long time off from training and you used to be able to run for an hour straight, no problem, you may fall into this fatigue category, okay, because your body is not able to produce the energy that you need to keep going because it's not trained to do so right now. So that's why training is really important. But you can also think of this as like the normal everyday, like fatigue that can occur because it can occur. I think yesterday when I was walking around Target to go grocery shopping, I got tired, I got winded because I'm just used to sitting at home all day. That's really silly of me to say that to you guys, but it's fine. So we have different forms of energy. We have mechanical, we have chemical, and we have electrical. So mechanical is going to come primarily from muscle contractions. Chemical is going to come from ATP, glucose, and fat. And then electrical is going to be any action potentials or nerve potentials or impulses that happen. Energy can be transformed from one type to another. An example of this would be turning ATP from that like cellular energy source into a muscle contraction. And then metabolism is going to be the sum of all of the chemical energy that transformations that occur within the body. So, adenosine triphosphate or ATP. ATP is our energy currency within those cells. So, without ATP, we would not have life. Our muscular work that requires the transfer from chemical energy of ATP to the mechanical energy is going to give us muscular contractions. Specifically, right, we're going to use these when we walk around or move on a day-to-day basis, or we can get complex when it comes to exercise and the movements that occur there. Muscle and liver ATP concentrations are very limited. So we do have to become like a powerhouse for building ATP if we want to go for long endurance time periods. ATP is going to produce energy when we have high energy bonds breaking. So this is a constant process that occurs, that as we create energy, we have a bond break. And so by breaking the high energy bonds between the last two phosphates and ATP, we have this exposed energy that occurs, and we can utilize that. So ATP at the top, this is our high energy form. When we break the bond, we have a low energy form, and it turns into inorganic phosphate and ADP, or adenosine diphosphate. Our energy metabolism, you guys, is this constant merry-go-round. So we have an ATP, we have an ATP, we do our daily lives, we break this bond, we get ADP, inorganic phosphate, we have enzymes that occur that come and create this back into an ATP form, where we have this constant cycle of ATP production and utilization so that we can live our daily lives. The mighty mitochondria. So our mighty mitochondria is the idea that the mitochondria are going to make a lot of the ATP that we need to use. They are known as the powerhouse of the cell for production of ATP for energy. So our mitochondria do us a really good job of creating ATP so that we can go on and have our energy to get throughout our day. Mitochondria is found within inside of our cell. I know, going back to a little bit of the biology day. So we have our cell and we have our mitochondria right throughout the cell. Mitochondria is where we have this primary form of ATP production. So what happens is we have this cellular respiration that occurs where inside of the cytoplasm, we have glycolysis that occurs. And then inside of the inside of the mitochondria, we have the Krebs cycle and electron transport chain that occur. So take home message on this slide, you guys, is just knowing where the different forms of how we get ATP, how they're created, and where they're located. So glycolysis is going to occur outside of the mitochondria, inside of the cytoplasm to create ATP. And then our Krebs cycle and our electron transport chain, which create a lot of ATP, are going to occur inside of the mitochondria. So what do we need to make energy? We first need mitochondria. This is going to be the furnace for making energy. We need fuel, so we need carbohydrates, fats, and proteins from those micronutrients we talked about earlier. We need helpers from oxygens and different enzymes, and we're going to go over that in the next section. We then have a product of ATP, and then we always will have some sort of waste product. And the primary ones that we have as humans are carbon dioxide, which then our plants can use, and then we have water. So this is like this big cycle that occurs every day without you even knowing, which makes it super cool, right? Like our body does all of this on its own, and then it gets even cooler when you think about what it has to do to do exercise. So we like to call mitochondria as like elite runners being walking mitochondria. So elite endurance athletes are often referred to as walking mitochondria because they have so many of them, and they're able to go and go and go. So if we think back to the slide with the guy that broke the marathon time, the amount of mitochondria that he has to have to keep that supply of ATP going so that he can continue to run that fast is unbelievable. And so we do have these controlled reactions through different enzymes, and our enzymes are going to be what we call like our late limiting factors to supplying energy to our cells. and creating the ATP. So energy is released and controlled by the rate based on the availability of a primary substrate. So if we have carbohydrate available, if we have fat available, the energy that is going to be released is based on those. Mass action effect is the more that we have available, the more that we can produce, right? So if we have substrate availability, we can have a metabolic rate that occurs and we can have this process of ATP production. The more available the substrate is, the higher the pathway activity. So like I said, if we have more substrate, like a carbohydrate available, the more that activity can be available. And then any excess of the given substrates, the cell will rely on the energy of the substrate more than others. So for example, since I am not a runner, yesterday I ran and I almost died. But my primary substrate is going to probably be through carbohydrate and glycolysis, right? So when I tried to run, my body relies a lot on like the carbohydrate and glycolysis based systems versus the ATP production that comes from inside of the mitochondria that can rely on fat and like the oxidation of the carbohydrates. So we can think of this as like fueling the car, right? We want to always make sure that we have fuel available for the car, and whatever type of gasoline we use is what is going to help make us go faster, right? Each step inside of this process, you guys, is a biochemical pathway that requires specific enzymes. So depending on the type of reaction that's occurring from a carb or a fat or the metabolic pathway that you're going to use through the Krebs cycle, through glycolysis, is going to have a specific enzyme. If we have more enzymes available or active, we're going to get more product. We're going to get more ATP. Rate limiting enzymes are going to sometimes create a bottleneck in the early steps because the body has to kick on that the enzymes are needed to help facilitate the process. And it's going to also be activated through negative feedback. So after we utilize the ATP and we break it down into ADP and inorganic phosphate, that will also create a stimulus for the enzyme. And the slow overall reaction is going to prevent a want to runaway reaction where we just create and are very wasteful. Our body likes to be very efficient. And so we always want to make sure that we only produce what we need and then we utilize and we save the rest. So you are only as good as your slowest athlete. So our enzymes, the way that they function is we are only as good as our slowest enzyme. So we have to train our body to utilize them properly and create the ATP when we need it to. So energy is going to be released at a controlled rate based on the enzyme activity of the metabolic pathway. So as we need enzymes released, it will be very controlled off of what we need. Enzymes are not the chemical reaction starter or the set point to yield ATP, but it does affect or facilitate the breakdown in the of the different substrates. The lower of the action energy on the chemical reaction, and then enzymes always end with the suffix of ase. So for example, ATP is broken down by ATPase. So if I can give you guys any type of just like take home message with this, is that when enzymes are active, everybody, this is going to be our rate limiting reaction. So when we have enzymes available, it means that we need it to help facilitate the breakdown of our substrate, our carb, our fat, our protein. We will also get an influx of enzymes when we have what we call negative feedback, where we have the ATP that's been broken down into ADP and inorganic phosphate. That will also allow an influx of enzymes to occur to help us continue to produce ATP. So this slide, you guys, it's going to be hard for me to record this, but do you guys see how my arrow, when you guys do this on your own and you click on here, it will take you through this animation, but I will walk you through it here. So we have ATP, that is our available energy. We have our fuel source, and then we have an enzyme that occurs, okay? So whatever the enzyme will depend on if it's glycolysis, if it's a Krebs cycle, if it's ETC or electron transport chain. This fuel will then go through a series of chemical reactions that will occur, and it will produce or help us produce ATP in this system. So essentially what this does is it just walks us through what that process looks like at a very topical level. And in the next section, we're going to get into, okay, with glycolysis, what enzymes are available. So I just want the big take home message here is just like globally, how do we look at this? And we're going to pick up with metabolism next.